Welcome everybody. Today we are going to begin our discussion of Chapter 10. Some special notes about Chapter 10. Your textbook does a really good job of explaining things, but it kind of goes in an order that Mrs. Mikeworth and I have decided we would rather change from. We traditionally have taught it in a little different sequence than your textbook, so you're more than welcome to reference your textbook, but throughout this chapter we will be posting tutorial videos and notes for the sequence that we feel like fits best for our class. In order for today's notes to make sense to you, you are going to need to have access to a calculator and a periodic table. If you don't have those items with you right now, I would encourage you to pause the video and go and gather them because you will need them. Today we are going to learn about molar mass and percent composition. So let's begin with a definition of what each of those terms mean. Molar mass is the mass in grams found in 1 mole of a substance. The units for molar mass are grams per mole, which can be abbreviated as G/mol. Now, I know that this doesn't make a lot of sense to you yet because a mole is not something that most people are familiar with, but moles are a really, really important unit of quantity in chemistry. The best real life comparison that I could make for that is a dozen. When I say that you have a dozen of something, that means that you have 12 of whatever it is. You can have a dozen eggs, a dozen shoes, a dozen people, a dozen feathers. But I think we can all agree that while a dozen feathers would mean 12 feathers, a dozen feathers is going to have a different mass than a dozen elephants would. While they both have 12 items in them, they'll have different masses. Elements and compounds are really similar. A mole of carbon will have a totally different mass than a mole of lead would have. And today we're going to work with how you determine that, because when you are in the lab, you can't really go measure out 2 moles of something. All of our balances measure in grams, so that would be much more useful unit to use. Percent composition is defined as the percent mass of each atom that the percent mass each atom contributes to the overall mass of the compound. I think the best way for us to understand this is to just get right to work on some sample problems. So, for each of these sample problems today, I want us to begin by writing the correct formula, calculating the molar mass, and then finding the percent composition. Chemistry is a class that really builds on itself. We have spent the last several days and weeks working on how to correctly write formulas, because if you can't write the correct formula, then finding the molar mass and percent composition is going to be difficult for you. So, the first compound that we're working with is magnesium nitride. So to come up with the correct formula for magnesium nitride, we need to think about what ion magnesium makes. Magnesium makes an Mg2+ ion because it's in the second column on the periodic table. Nitride, it's an ide, so that's a negative ion. Nitrogen will make a -3 ion. Because it needs 3 electrons to become stable, like a noble gas. So once we get our charges, then we have to crisscross our numbers here. And this will give us a formula of Mg3N2. That is the correct formula for magnesium nitride. Now, to determine the molar mass of magnesium nitride, this is what we must do. You must start by listing what elements you have. We have magnesium, and we have nitrogen in this compound. Then we must list how many atoms of each element you have. So if I look at the formula, there's a subscript of 3 next to Mg, so that means there's 3 magnesiums. Nitrogen has a subscript of 2, so there's 2 nitrogens. Next, we are going to need to look at the periodic table to figure out what the mass of each of those elements are. So as you look at the periodic table and you find the box for magnesium, the bottom number on that box will tell you what the mass is. The mass of magnesium should be 24.30. Now, please understand that this will vary depending on which periodic table you consult, because they may not always round to 2 decimal places. You do not need to keep 5, 6, 7 decimal places. 2 decimal places is sufficient for what we are doing. So we would take 3 times 24.30 to find what the mass of magnesium is. I have that 3 times 24.30 works out to be 72.90. Next, we look up what the mass of nitrogen is on the periodic table. When I look that up, I find the mass of nitrogen is 14.01. So I have to take 2 times 14.01, and that gives me 28.02. Now, what we must do to find the total molar mass of magnesium nitride as a compound is to add these numbers together. So when you take 72.9 plus 28.02, I get a total mass of 100.92, and we would label that as grams per mole. So what that means is every 1 mole of magnesium nitride is going to have a mass of 100.92 grams. Next, we need to find the percent composition. To find the percent that is magnesium in this compound, I need to take the total mass of magnesium in the compound, which we had just determined is 72.90 grams, divided by the total mass of the compound, which is 100.92, and we will multiply by 100%. Now let me tell you, when you plug this into your calculator, you need to put 72.90 divided by 100.92, and you should multiply by 100, but please don't use the percent button on your calculator because it will multiply by an additional 100. So just multiply by the number 100, hit equals, and write a percent sign at the end. I have, when you do that, you should get around 72.2% magnesium. All right, we must also determine what percentage of this compound is nitrogen. So I need to look and see what's the total mass of nitrogen in this compound. It's 28.02 according to our work shown above. We divide by the total mass of the compound, multiply by 100%, and I have, when you plug that into your calculator, you should get roughly 27.8% nitrogen. And those are our answers. Some common mistakes that I see students make, I'll put these in red so that you know that they're not correct. If you go to determine the percent magnesium, I don't want to see something like this, 24.30 over 100.92, because yes, the mass of magnesium on the periodic table is 24.30, but in this particular compound we have 3 magnesiums, so you can't just use the mass of 1 magnesium, you have to use the mass of all 3 of them. That's why it's better to use the 72.90. All right, practice makes permanent. Hopefully it also makes perfect if you're practicing correctly. So let's move on to the next sample. Iron 3 sulfate. Iron 3 is Fe plus 3. Sulfate, it's an 8 ion, so it's got some of those oxygens and is negative. It's SO4 2 minus. So I'm going to need to crisscross my superscripts into subscripts, and this will become Fe2. Then we have to put the sulfate in parentheses because it stays as a unit, and we need 3 of them. So we will put 3 on the outside. All right, next, to find the molar mass, I'm going to do what I did up here. Remember, I listed what elements I had and how many. So in this compound, I have iron, I have sulfur, and I have oxygen. There are 2 irons because it has a subscript of 2. Sulfur. To determine how many sulfurs there are, we must first look that there's 1 sulfur in sulfate, but we have this 3 outside of parentheses. So outside of parentheses, that means that there's 3 times the amount that's inside of those parentheses. So 3 times 1 tells me that there are 3 sulfates. For oxygen, I'm going to do the same thing. I'm going to take 3 times 4, and 3 times 4 is 12. So there are 12 oxygens. Now, if we look back to our last problem, after we listed how many of each atom we had, we multiplied by the mass on the periodic table. So take a look at your periodic table. The mass of iron is approximately 55.85 grams per mole. So I take 2 times 55.85 and I get 111.7. I next need to look up sulfur. Sulfur has a mass of 32.07. So I'm going to take 3 times 32.07, and I get 96.21. Oxygen. Now, if you look at oxygen, a lot of periodic tables will list it as 15.9994. So I just generally round that to 16 for the mass of oxygen. 12 times 16 is going to give us 192. So to find the total mass of the compound, I've got to add all of these up. So I take 192 plus 96.21 plus 117.7, and I get a mass of 399.91. And our unit label, remember, is grams per mole. So there's your molar mass. Next, we must find the percent composition. So we've got to find the percent that's iron, the percent that's sulfur, and the percent that is oxygen here. So for iron, the total mass of iron in the compound, if we look back at our calculations, was 111.7. We're going to divide by the total mass of the compound, 399.91, multiply by 100%, and I get the value of 27.9%. And it's probably best if we label that as percent iron so that I know that that's the percentage that goes with iron. Next, we can find the percentage sulfur by taking the total mass of sulfur, which is 96.21, divided by the total mass of the compound, 399.91, multiply by 100%, and I get, let me see here, I get 24.1% sulfur. For oxygen, the total mass of oxygen is 192 divided by 399.91, multiplied by 100%, and I get 48% oxygen. So there would be your percent compositions. Now, a really good way to check yourself is all of the percentages in a compound should add up to be 100% if it's parts of the whole. So let's try that. Let's take 27.9 plus 24.1 plus 48, and that adds up to exactly 100. So we're good to go. That's a nice little way to check to see if you've done this right. All right, our third and final example of today's lecture is for us to find the molar mass and percent composition of diphosphorus pentachloride. Don't let these prefixes fool you. Type 3s are very easy. Di means 2. Phosphorus is P, so P2. Penta means 5. Chloride is with chlorine, so it's P2Cl5. So next we will list that we have 2 phosphorus. We have 5 chlorine. We're going to look up their masses on the periodic table. The mass of phosphorus is 30.97. So 2 times 30.97 gives us 61.94. Chlorine, if you look it up on the periodic table, is 35.45. So 5 times 35.45 gives us 117.25. To find the total molar mass, I need to add those values, and I get 239.19. My unit label would be grams per mole. We're close to done, but not quite there, because now we need to find the percentage that is phosphorus and the percentage that is chlorine. I have for phosphorus, the total mass of phosphorus in this compound was 61.94. We're going to divide by 239.19, multiply by 100%, and I get 25.9% as my percentage for phosphorus. Feel free to pause the video and double check that that's what you get on your calculator as we go through. Chlorine, I'm going to take the total mass of chlorine, which is 117.25. I'm going to divide that by 239.19, multiply by 100%, and I get 74.1% chlorine. And if we use our method of checking and we add 25.9 to 74.1, I get 100. Now, if you add them up and you get like 99.9 or 100.1, that's close enough to 100 and probably is just an issue of rounding, and that's not a problem. Please also know that there will be some variance depending on which periodic table you use and how many decimals you round each number to, but you should be in the same ballpark regardless of what periodic table you choose to use.